Lesson 13.4, we're looking at inverse trigonometric functions. I'm going to start off with a reminder that when we're dealing with a unit circle, that sine theta is equal to y, cosine theta x, tangent theta is y over x, and our second column, our cosecant, secant, and cotangent are just reciprocals. Previously, we've evaluated trigonometric functions of a given angle, but today we're going to be doing the reverse. We're going to find an angle that corresponds to a given value of a trigonometric function. So previously, you may have been asked, what is the sine of pi over 3? So remembering that sine is the y value, we would go to our unit circle. We find pi over 3, the y value is equal to the square root of 3 over 2. Today you are asked, what is the angle whose sine is square root 3 over 2? So now our answer is going to be equal to pi over 3 or 60 degrees. This is called arc sine or inverse sine. Your book calls it inverse sine, but we're not going to call it sine to the -1. Arc sine or inverse sine. Because sine is a y value, theta is going to fall between negative pi over 2 and pi over 2. And let's take a look at why that is. So if I had a point on my circle here and a point on my circle here, these y values are the same, and we want to avoid repetition or duplicate answers. So we're not going to count the point on the left-hand side in quadrant 2. So all our answers for arc sine or inverse sine are going to fall in quadrant 1 and 4. We might also call this negative 90 degrees and positive 90 degrees. And finally, if we were to use interval notation, remember it's closed because we have the equal to bar. So we have negative pi over 2, comma, pi over 2. We know that when we're working with cosine, we're talking about the x values. So if I had a point here and a point here, the x values are going to be the same. Again, we want to avoid duplicates. So if I put a point over here, these two x values are different. So all our answers for inverse cosine or arc cosine will fall up above. I've added a couple things to the screen. Notice in the first diagram I forgot to label, or maybe it'll be helpful if you see if I label the 90 degrees, the negative 90 degrees, and we know that negative 90 degrees, if it's a full circle, is 270. And then because we're dealing with half of the circle, we have pi over 2 and negative pi over 2. Then I've also included the domain restrictions in green for arc cosine. And again, the interval notation has brackets because it has the equal to bar underneath the less than symbol. Finally, we have our inverse tangent or arctangent, and it's slightly different. It's very similar to our inverse of sine, but you'll notice that there's no equal to bar underneath it. So first of all, the part of the circle that we're going to be using is the same as for inverse sine. The one difference is, if you'll notice kind of lightly, you'll notice that it's 0, -1, and 0, 1. So what happens here, oops, let me get that in there, we would say y divided by 0, and that is undefined. So we cannot include the point at the top of our circle and the point at the very bottom of our circle. So that is why our interval notation has regular parentheses. All right, let's start with an easy one. Let's try arc sine of square root 2 over 2. So remember, when we're dealing with sine, we're dealing with this part of the unit circle. We know sine means it's a y value, so we look at the y values and we find square root 2 over 2. So our answer, it depends if we want an answer in radians or degrees, but our answer is going to be 45 degrees or pi over 4 radians. So now we're looking at arc sine of negative square root 3 over 2. So we're going to find negative square root 3 over 2. We're still looking at our y's, and it's down here. So it looks like it should be these values. But we have to think back to our restrictions, and our restrictions said it had to be between negative 90 degrees and 90 degrees. So we have a problem here. So now we're going to look up above and find something that's comparable. So going back up here, we found something similar, square root 3 over 2. So we can use these values, but again, because it's below the x-axis, we're going to call it negative 60 degrees and negative pi over 3. Our next one is arc cosine negative square root 3 over 2. If we remember from our previous slide, our answers are going to be between 0 and 180 degrees. Also, because we're dealing with cosine, we're looking at the x values this time. So we're looking at x values, negative square root 3 over 2. Here it is. So here's my degree and radian answer. We haven't tried arctangent yet, so we have arctangent square root 3 over 3. Things we need to remember for tangent. First thing, our answers are going to fall on the right side of the circle, and the other thing we need to remember is that it's y over x. So this isn't quite as straightforward as some of the other ones. So what we're going to do is, because we have square root 3 over 3, we're going to look at our values that have a square root 3 for a y value. No, a square root 3 that is as a y value or an x value, but we don't want to consider any negative values. So first we're going to just try maybe this ordered pair and this ordered pair and work to see if we could get it to be square root 3 over 3. All right, we'll start with this one, and remember it's y over x. So square root 3 over 2 over 1/2. We know that this means square root 3 over 2 divided by 1/2. So really we're going to multiply by the reciprocal, and when we multiply by the reciprocal, the 2's cancel, so we end up getting square root 3. So not quite a match. So we're going to go to our second try. All right, so I think I did a bunch of talking just now and it didn't record, but over here I ended up choosing this ordered pair, divided, switched it, multiplied, rationalized the denominator. So when I got square root 3 over 3, because we have a match, we know that the answer is going to be 30 degrees or square root over 6. I think I need a break. It's pi over 6, not square root over 6, pi over 6. So this is our final answer.